Let's look at one more example of proof by contradiction. So let's look at the example. Let's prove that no integer is both even and odd. So let's start out our proof. Remember how our proof goes. If we're doing proof by contradiction, we assume that what we're trying to show is false. So we're trying to show that no integer is both even and odd. If that's false, then there is an integer that's both even and odd. So suppose, for the sake of contradiction, there is at least one integer, and let's give it a name, little n, that is both even and odd. So now we want to use the definition of what it means to be even and odd. So by definition of even and odd, if n is even, it has to be 2 times a number, 2 times a, and if it's odd, it has to be 2 times some other number, 2 times b plus 1, for some integers well, if you look at your proof, you have n equal to 2a, and n is also equal to 2b plus 1. So now I can set those two things equal because they're both equal to n. And let's go ahead and get all of our variables on one side. If I look on the left-hand side, you can factor out a 2 out of here. And if I divide by 2, I get a minus b is 1/2. And I claim that we've already got our contradiction. Think about what a and b are. A and b are integers. So since a and b are integers, a minus b is also an integer. But a minus b is 1/2, and that's clearly not an integer. So on one hand is an integer, and on the other hand it's 1/2, so a minus b is not an integer, which is a contradiction. So we've reached step 2. We've got our contradiction. So I conclude that the original statement must have been true. Therefore, no integer is both even and odd. And that completes our proof there.